So we've defined the idea of equilibrium in the demand and supply model. We've talked about why the equilibrium is an equilibrium, and implied in that is why it's stable. Because essentially, once we have a price, if things sort of accidentally bump higher than the equilibrium price, there are going to be forces that force it back down. Namely, there's going to be a surplus of unsold goods at any price higher than the equilibrium price, and that's going to push prices back down. Likewise, if price somehow accidentally bumps lower than the equilibrium price, there's going to be a shortage, and that's going to push prices back up. But obviously, prices don't just stay at one level all the time. Things happen, and prices change. And the way we usually think about this is that prices are stable in markets until some event happens. And an event would be something like there's a war in the Middle East and that disrupts oil supplies, or lending becomes much more lax and people are able to get home loans, and that increases the demand for housing. So the way we usually do this, and I very much encourage students to follow this rigorous step-by-step process here, is to first we think about setting up our workspace. We sort of draw an initial supply and demand diagram and identify the initial equilibrium price and quantity. And then we think about the event and think about which curve or curves the event will affect. Most events are just going to affect supply or demand. Once we've decided which curve or curves are going to be affected, then we're going to go ahead and figure out whether or not the curve shifts left or right. Remember, if we have a lower level of demand or supply, we shift that curve to the left. If we have a higher level of demand or supply, we shift that curve to the right, because left is less and right is more. Then, once we've shifted the affected curves, we're going to find the new equilibrium. So we're going to find the new equilibrium and compare the new equilibrium with our initial equilibrium. And we're going to think about how the transition between the two equilibria has affected price and quantity. And that's typically the kind of ultimate punchline that we're interested in these sorts of problems. How has the event affected the equilibrium price, and how has the event affected the equilibrium quantity? When we're doing all this, it's important to remember the distinction between a shift of the whole curve and a movement along a curve. Remember that a shift to a whole new supply curve represents a change in the overall level of supply, represents a fundamental change in how much suppliers are willing to sell at every price. Contrast this with a movement along the supply curve. A movement along the supply curve represents a situation where the price has changed, and that changes the amount that sellers are willing to sell. Likewise, the shift to a whole new demand curve represents a fundamental change in the overall level of demand, where a movement along a fixed demand curve represents people want to buy more or less because the product has become cheaper or more expensive. So, on this page are several example problems, and I want you to go ahead and actually try to draw these out on paper using that step-by-step process earlier in this video segment. And I'll go ahead and let you pause the video now, and then I'll run through how I would analyze these problems. For this first problem, the market for rice, which I've identified as allegedly an inferior good, what happens when incomes rise? Well, remember that inferior goods are goods that when people have higher incomes, they buy less of it, possibly because they upgrade to something else that meets the same need. So as incomes rise, that means consumers want to buy less at every price. So instead of curve D1, we're now at curve D2, which is to the left of D1, and our new equilibrium is here at the intersection of the original supply curve and the new demand curve. The supply curve doesn't shift because essentially the costs and other determinants of supply haven't changed. It's not that fertilizer has become cheaper or more expensive, or government regulations have made growing rice easier or harder, or anything like that. Basically, all that's happening is that suppliers are reacting to the change in demand. In particular, what they're reacting to is that at the old equilibrium price, which is here, there's now a surplus of unsold goods, because at the old equilibrium price, quantity demanded is here, and quantity supplied is here. So there's a surplus, and that surplus puts downward pressure on prices. That downward pressure on prices causes demand to somewhat recover from the earlier drop and causes suppliers to want to supply less. The second problem considered what would happen to the market for natural gas if fracking becomes invented. So fracking is a technology that allows natural gas to be extracted from places where natural gas couldn't be extracted before. So at every price, more natural gas is available. So we shift the demand supply curve to the right. So we started at equilibrium 1, and at the old equilibrium price, there is also a surplus in this problem of unsold natural gas, because at the old price, people want to buy this amount here, but people want to supply where that price hits the supply curve, and then down here they want to supply this quantity. So there's a surplus of unsold natural gas, and that surplus of unsold natural gas puts downward pressure on prices, and eventually we end up with this in equilibrium here. So we end up with a decline in prices and an expansion of the quantity transacted. What about problem 3? The market for biodegradable plastic, and people become more environmentally conscious. Well, if people become more environmentally conscious, they have an increased demand for this biodegradable plastic. And what happens then is we have the demand curve shift to the right, because left is less and right is more. So we have an increase in the price of biodegradable plastic and an increase in the quantity as we transition between equilibrium 1 and equilibrium 2. Problem number 4, consider the market for diamonds. And suppose that civil war breaks out in South Africa, which is one of the world's most important diamond suppliers. Well, if civil war breaks out in one of the most important suppliers, then we're going to go ahead and see that there's a lower overall supply of diamonds available. A lower or lesser level of supply is a leftward shift, because left is less and right is more. So we shift the supply curve to the left, and we see that we shift from equilibrium 1 to equilibrium 2. So we see that quantity falls and prices rise. Market problem number 5 considered the market for houses. And in this case, I've said that both buyers and sellers expect house prices to be higher next year. So the idea here would be that if buyers, the demanders of houses, expect prices to be higher next year, they want to buy now to avoid paying those higher prices. So current demand for houses increases as buyers try to sort of beat out the clock. On the other hand, sellers, if they expect house prices to be higher next year, that makes it less appealing to sell this year because they might like to hang on and sell next year for a higher price. So sellers actually experience a decrease in the amount they're willing to sell, or a leftward shift in the supply curve. So we started here at equilibrium 1 at the intersection of S1 and D1, and then we end up here at equilibrium 2 at the intersection of S2 and D2. And this is sort of an exceptional case. Most events will only affect either the supply curve or the demand curve, but this one operates on both. And I sort of made sure to clarify here that it affected both buyers and sellers' expectations. Notice that we're pretty clear that there's going to be an increase in price. The overall increase in quantity is a little bit tricky here. As I've drawn it, it looks like quantity is pretty much the same. Maybe there's a slight increase in quantity if you squint really hard. But that's going to depend upon the relative magnitude of the supply curve shift and the demand curve shift. You can see that if demand had shifted out less, if the demand curve were here, say, our new equilibrium would be here. We would still have higher prices, but quantity would have fallen. Likewise, if the supply curve shift had been less, and it had only been out to here, we would have had our equilibrium here. We would have had higher prices, but quantity would have actually grown. Whenever we have both curves shifting, we're going to have those shifts reinforce each other, either on price or on quantity, and then contradict each other on the other variable. So in this case, they reinforced each other on price. Both higher demand and lower supply tend to push up price, but they contradicted each other on their effect on quantity. So the overall effect on quantity is going to depend on the size of the shifts. Market, or problem number 6, considered the market for chicken and said that a plague strikes the chicken population. And there's a couple different interpretations you might go with here. And that's going to be a general feature of modeling demand and supply. There's often going to be some ambiguity, and we have to sort of use an element of judgment to think about which curve is going to be importantly affected and which curve is going to be only minorly affected. So in this case, in 6a, I've supposed that the plague kills some chickens, but essentially consumers don't care. Well, in that case, we have a lower overall level of supply. This S2 should be over here. And a lower overall level of supply is a leftward shift because left is less and right is more. And so we move from equilibrium 1 to equilibrium 2. We have an increase in prices and a decrease in the quantity transacted. We might also think that when chickens start getting sick and dying, that impacts both the number of chickens there are and it makes consumers afraid to eat chicken. I've actually mislabeled the curves here. This should be a leftward shift. So let's pretend that this is D1 up here, and this should be D2. So if consumers are afraid to eat the chicken, they would shift their demand to the left, and we would shift from the intersection of what is supposed to be D1 here and S1 right here to the intersection of S2 and what's supposed to be D2. If there's a leftward shift in demand and a leftward shift in supply, we can be pretty sure that quantity is going to decrease because both a fall in demand and a fall in supply cause a decrease in quantity. But the impact on price is kind of uncertain. As drawn here, it looks like probably price decreased by a tiny amount. But if you sort of play around with it, you can see that if the demand drop was relatively minor, then we would actually have an equilibrium right here, and prices would rise. On the other hand, if the supply drop was minor compared to the demand drop, then our supply curve would run through here. We would have an equilibrium about right here, and we would actually have a price decrease. And this comes back to that idea that if both curves are shifting, they're going to reinforce each other on either price or quantity and contradict each other on the other variable. So in this case, a fall in demand produces a decrease in quantity and a decrease in price, and a fall in supply produces a decrease in quantity and an increase in price. So we're really confident that there's been a decrease in quantity, but predicting exactly what happens with prices is a little bit trickier.